So for this question, it's about caprotic acid. It's the substance responsible for goats and dirty socks. It contains carbon, hydrogen, and oxygen. Combustion analysis of a 0.450 gram sample of caprotic acid gives 0.48 grams of H2O and 1.023 grams of CO2. What is the empirical formula? This is a combustion analysis problem, and the combustion analysis will give us the empirical formula of carbon, hydrogen, and oxygen. So the first thing we want to do is we want to calculate the moles and the grams of carbon found in the CO2. To do that, we're going to calculate the grams of carbon and the moles of carbon found in 1.023 grams of CO2. To do that, we're going to convert grams of this to moles of CO2. So there are 44.01 grams of CO2 and 1 mole of CO2. Now we're going to convert moles of CO2 to moles of carbon. There's 1 mole of carbon in CO2, so we're going to stop the calculation here, and so we get 0.0232 moles of carbon. Now we'd like to find the grams of carbon, so we will, in 1 mole of carbon, there are 12.01 grams, which gives us 0.27916 grams of carbon. Okay, now we're going to do the same thing for the hydrogen found in the water. So in order to do that, we're going to convert the mass of water to the moles of hydrogen and the mass of hydrogen. So in order to do that, we'll use the molecular weight of 18.02 grams in 1 mole of water. So in 1 mole of water, there are 2 moles of hydrogen. So that is 0.04639 moles. Now we're going to convert that into grams in 1 mole of hydrogen. There are 1.01 grams of hydrogen, which is equal to 0.0468 grams. Okay? So in order to calculate the empirical formula, we're going to compare the amount of moles. But right now we have the moles of carbon and the moles of hydrogen. We need the moles of oxygen. First, we need to find the grams of oxygen, which we can then convert into moles. In order to do that, okay, so we're going to use the total mass and then subtract out the mass that corresponds to carbon and the mass that corresponds to oxygen or to hydrogen. That will give us the remaining mass that is contributed to oxygen based on the law of the conservation of mass. So 0.450 grams minus 0.27916 grams of carbon minus 0.0468 grams of hydrogen equals 0.12404 grams of oxygen, which we will now convert into moles. So there are 16.00 grams in 1 mole, which equals 0.00775 moles of oxygen. So the fourth step is to, now that we have the number of moles of each of these, we can divide by the least moles to determine the empirical ratio. Okay, in this case, if we have carbon, we have 0.0232 moles. For hydrogen, we have 0.04639 moles. And for oxygen, we have 0.00775 moles. So we'll divide this by the least moles. Which is equal to 2.99, which is approximately equal to 3. In this case, we'll also divide this by the least moles, which is the moles of oxygen. Which is equal to 5.98, which is well within the reason to not have to use fractions. And so we will now say that's approximately equal to 6. And for our last one, 0.00775 divided by itself is equal to 1. And so our empirical ratio, or our empirical formula, is C3H8O6. Sorry. So in that case, this is how you use combustion analysis to calculate the empirical formula. You first find the moles and grams of carbon, then find the moles and grams of hydrogen, do the same thing for oxygen. Then you use the moles to calculate the molar ratio in the empirical formula.